This is section 4.7, and I'm on page 13. The example says, find the area of the largest trapezoid that can be inscribed in a circle of radius 1 and whose base is the diameter of the circle. So two things obviously in here is a trapezoid and a circle. I put the trapezoid picture up at the top of the page along with the area formula, and then I also drew a circle with radius 1. So looking at this closer, it says find the area of the largest trapezoid that can be inscribed inside a circle, and the circle has radius 1 and whose base is the diameter. So base is the diameter of the circle. So first thing that we want to do is it looks like we are maximizing since it says largest. So we're going to go ahead and maximize the area of the trapezoid. The area of trapezoid. I'm going to go ahead and copy down the equation that we have up above. Okay, and I have a constraint here. I can't make this as big as I would like to. The constraint which is controlling this is that it has to be inscribed. It's our key word here. So this has to be inscribed in this circle. So if I come over to my circle, that means that I have to draw my trapezoid in this circle. The base of the trapezoid has to be along the diameter of my circle. So I'm going to go ahead and draw the base in here first. So our base is down here at the bottom of it. And obviously the biggest one that I can make, the largest trapezoid that I can make, would have to go all the way up to that circle. So I'm going to go ahead and put a point up here, and I'll draw my diagonal line, and we have to go across and then back down to that far left point. So there's my trapezoid that I have. I need to kind of reference this in some way, and I'm going to say this value that we have here, this point, I don't know where exactly it's located. And if you notice, I put my circle on axes here, so I have my x and my y, so that way I can put the radius of 1. I have it centered at 0, which makes it the easiest thing at the origin, 0, 0. It could be centered anywhere, but again, it just makes it easier to deal with if it's centered at 0, 0. And I have a point there that is x, y, that's defining the size of my trapezoid. So the base of the trapezoid here is 1. And if you look at the second base up here, this half of it, that length there is going to be x. And that means that this other part of the base over here on the negative x side would also be an x. And then the other value that we need to find in our trapezoid would be the height, which is a vertical line straight down from one base to the other. And this height, since I defined my point as x comma y, the distance of that is just y. So if I look at the formula that I used over here, I have B2, which is the bottom of it. Well, I have my base on this side is 1, and the base over here on this side is also 1. So B2 is 2. And B1, which is up here at the top, is x plus x, or just 2x. And then my height isn't h, but my height is going to be y. So defining it the way that I set up here, and again, we could have used the variables that were in the other equation, but I'm just going to go ahead and substitute those in over here for my area formula. So I'm going to rewrite my area formula as 1/2 y times base 1 was 2x, plus base 2 is 2. And I need to have a constraint equation. So we need a constraint equation. And our constraint equation is what's controlling this. Again, it's just being controlled by that size of that circle. So we need to have an equation for our circle. And our circle, an equation for the circle is going to be, since we have it centered at the origin, It's going to be x squared plus y squared equals r squared. If you guys remember, there is a formula back in Algebra 2 that was x minus h squared, then y minus k squared equals r squared was the general form of a circle. So this is our equation for the circle, and we do know that the radius is 1. And so this just simplifies to x squared plus y squared equals 1. And my constraint equation is what I use to solve for one of my variables to substitute into the other equation, the one that we're trying to maximize or minimize. So I'm going to go ahead and solve this. I'm going to solve it for y, but again, it doesn't really matter. If you solve this for y, you're going to have plus or minus the square root of 1 minus x squared. And I am going to only use the positive one. If you guys remember the equation for a circle, it gives you guys two equations. There's a positive one, which is the top semicircle, and the negative, which is the bottom semicircle. And how I chose to draw out my trapezoid was in the top. So I'm going to use only the positive one. So I have y equals the square root of 1 minus x squared. And this is for the top semicircle. So our top semicircle. So once we have this, we are going to go ahead and substitute our constraint into our equation up above. And I'm actually going to first, well, we can simplify it later, but we will substitute that in. Before we do that, though, I'm going to go ahead and rewrite this. And if you notice, you can factor out a 2 from your parentheses, and it will simplify with the 1/2. So this will become y times x plus 1. And so we will substitute it into our simplified equation, which is here.